Hello everyone and welcome to our final year project video. We are Haya Bugs, and our project is source separation and fault detection using multiple machine vibrations. Introduction. Source separation involves isolating individual signals that have been mixed together. There are three main areas in the domain of source separation: music source separation, speaker source separation, and machine source separation. But compared to the other two domains, machine source separation is a rarely considered research area crucial for machine fault detection. In the industrial environment, it is unavoidable that the signals from one machine can be influenced by the signals of surrounding machines. Therefore, special attention should be given to source separation before conducting fault detection. Problem statement. The problem we are addressing is isolating the intended machine vibration signals prior to the fault detection of the particular machine, because the signals that are captured by the sensors connected to the intended machine can always be influenced by the signals of surrounding machines. So as the solution, we proposed a machine learning-based approach for conducting source separation to isolate the vibration of the specific machine and then use the separated vibration data for fault detection. Objective. Our main objectives are performing source separation to isolate machine vibration of the target machine, utilizing the isolated vibration data obtained from the source separation stage for the intended machine's fault detection, and developing a software product to enhance the usability of the model. Novelty. As the novelty of our project, we explored a new data domain for source separation. According to the literature, so far used domains in source separation are waveform and spectrogram data. So our contribution is using a feature-extracted data set to conduct machine source separation.
Sensor setup. In the selected industrial environment, all 21 machines are located on the same factory floor, and the specific machine that is going to conduct fault detection is the multi-wire drawing machine, which is indicated as Machine 2. It should be mentioned that the other 20 machines are different from Machine 2. For Advantech 2410 LoRaWAN, sensors are connected to the key bearings of Machine 2, and these sensors provide 3-axis detection and real-time monitoring capabilities. Machine status is collected using a separate sensor setup. Data set. 8 features are collected by each axis: velocity RMS, acceleration peak, acceleration RMS displacement, kurtosis, crest factor, skewness, and standard deviation. Machine status data includes 4 states as on, off, unknown, and unrelated. ISO standards provide information on machine faults. By using the velocity RMS value, which is one of the sensor's output features, and the machine's horsepower, we can label the level of machine faultiness. Methodology. Our proposed architecture mainly consists of 2 main parts: generative adversarial network for source separation and 1 class SVM for fault detection. This diagram shows a high-level idea of the proposed architecture. The GAN model mainly comprises 2 main components: the generator and the discriminator. Next, we do a deep dive into the GAN model's internal operations for our approach. To train the GAN model, we labeled our dataset as pure and noisy data. Initially, we trained the discriminator using real data. There, the discriminator acts as a classifier, and with training, it will be able to classify the input data as pure or noisy data. Then we hold the training of the discriminate and start training the generator model. The generator acts as an autoencoder, which has 2 main parts: the encoder and the decoder. We feed the input data to the generator, and the encoder creates the latent space using the important features of the input data. After that, the decoder module recreates the pure machine vibrations using the latent space data. Then, the generated data will be fed to the discriminator. Since the discriminator already trained to classify the input data as pure and noisy, generated data of the generator model will be classified accordingly. Further, the classification error of the discriminator will back-propagate to the generator. Learning from the propagation loss, the generator tries to recreate the pure data as accurately as possible. Let's move on to the fault detection part. After the source separation stage, the separated data was labeled, and almost all the data points in the dataset were healthy. Since the dataset is biased for one class, which is the healthy class, OCSV is used for fault detection. There, The model learns the boundary around the healthy data points, and all of the points outside that boundary are considered unhealthy or faulty.
Evaluation metric. For the source separation task, we use the signal-to-noise ratio as the evaluation metric. Higher SNR values indicate reliable pure signals, and SNR values greater than 20 decibel are considered as favorable outcomes, indicating better source separation. But to calculate the SNR value, we needed pure and noisy signals at the same timestamp. We didn't have both signals in the same timestamp, therefore as the solutions, we calculate the SNR value using the pure signal from the nearest timestamp and evaluate the model's performance with different benchmark datasets. Results. Under the Results section, we consider selecting the source separation model, enhancing the experiments of GANs, selecting the fault detection model, and implementing the software product. Results with independent component analysis. We initially trained the ICA model for source separation, and experiments were conducted using different step sizes for the model. There we achieved the ASNR value of 1.73 for step size 0.005, but clearly the SNR value is below the threshold value for quality source separation. Results with GANs. For the GAN model, we changed different parameters for optimization. There we considered three main parameters, which are hidden layer type, number of nodes in a layer, and the activation function used in the hidden layers. For each experiment with different configurations, we tested the model with experiment benchmark datasets as well. This table shows the summary of the experiments that have been conducted. SNR values achieved by our dataset, along with the benchmark datasets, are shown under the last column for each different configuration of parameters. The highlighted rows indicate the highest SNR values that were achieved by the model. These diagrams show the generator and discriminator performance under our dataset and the benchmark datasets. Results with fault detection. As the fault detection model, we trained two separate models, considering the formation of our source-separated data seed. There, the one-class SVM model outperformed the isolation forest model by achieving an accuracy of 0.96. These graphs illustrate the outcome of the fault detection models. The first graph shows the fault detection of the one-class SVM, and the second graph shows the fault detection of the isolated forest model. In both graphs, red dots indicate the faulty data points, whereas blue points represent the healthy data points. Software application. This application provides two main options for the source separation task. Option 1 is to directly select the machine-to vibration file and then proceed to source separate the data. In Option 2, the user has to select the vibration data file along with the machine status file as well. After mapping those two files, machine-to data points will be used for source separation. In both scenarios, separated data will be shown in the below table, and a graphical representation of the input data and separated data is shown above the table. It will provide the functionality to download the separated data file as a CSV file. Then, by clicking the fault detection button, it will indicate whether the machine is faulty or flawless. Conclusion. The optimized GAN model improves signal-to-noise ratio values for both NASA and CWRU data sets, highlighting the influence of architectural configurations on performance. The proposed approach combines GAN source separation and SDM fault detection, achieving good results in isolating machine vibration signals and accurately detecting faults. That's about our final year project. Thank you for watching.